Hey guys, so today I had given you, as far as your classwork, a simulation through the PhET program, and it has to do with isotopes and atomic mass. So this is the handout that you guys got. So it's pretty straightforward, just like the build an atom simulation, but there's a couple of things that I want to bring your attention to. So when you get to the last page, okay, make sure if it says write some observations, I'm looking for you to have written something here, okay? So I'm not worried about what your observations are, but make sure that you've done a complete job, okay? And then when you get to the abundance in nature, all right, I want to show you, give me just a second. So I wanted to pull up the simulation and show you where it says abundance in nature. How do you find that? So there was one of the options for the simulation that said isotopes, okay? And whenever you're there, there's a window that has abundance in nature. You need to make sure that you maximize everything, okay? But the abundance in nature, you would just write down this amount, all right? So for hydrogen, it has different isotopes. We're going to take notes on just definitions and different key points that I wanted you to get from the couple of simulations that you've done. But as you add neutrons, notice that's the only thing that you can change, okay? You can select which element you want from up here. But as far as the neutrons, that's the only thing that you can change. And notice that it changes what your mass number is. It changes the symbol, okay? So this is the isotopic symbol notation. And then you also are told about the abundance. So this is really important. It asked you a question about that, but that's one of the things that we're going to look at on the last page, because a lot of people tend to have questions about that. Notice also, depending on how many neutrons you've got, that's also going to affect the stability, okay? So then there's another tab that says mixtures. So the mixtures tab is what you're going to use when you get, okay, to number 7. Number 7 is it's now called mixtures. They've updated the simulation. It was called mixed isotopes. So up until that, you're just writing everything down from the isotopes tab, and then starting at number 7, it's called mixtures, okay? And you are literally looking at this part, and notice that this is very close to the same picture. They've updated the simulation since then. And you have my mix and you have nature's mix that you can select. So for hydrogen, this is what it looks like in nature, but you can manipulate that. Now, when you're using your cell phone, it's a little bit harder to like click and drag and change things. So you can actually click in here and you can type in an amount. I think that's where we can do that. And anyway, change that, and then there's also nature's mix, which tells you the different amounts. But I thought I would show you that. There's also, oh, here it is. This is where you can manipulate how many of which isotope without having to drag a certain number. You can tap on that and you can change the number, or you can just slide this to change the amount. Okay, and then it shows you what its average atomic mass is. We'll talk about that, because average is a little bit of a misnomer. It's really going to be a weighted average, kind of like your class grade. Your class grade is an average, but it's a weighted average. The summative weighs more heavily into your class average than the formative. So it's a weighted average. Some components weigh more. So that brings me back to your questions. Okay, so this one's going to be pretty straightforward. This is telling you, you don't have to label that, it's just telling you to make sure you maximize it. This is giving you directions, make sure you are adding your observations. And number 9, you are literally just writing in what the data tells you based on these numbers. And again, when you get to like 20 and 50, you're going to have to use that little slide and move it there. So then people tend to do good until they get to number 12. And they're like, I don't know how to answer this. So here's how you would approach it. You're completing some information, and then you're going to draw some conclusions between what the abundance in nature is and the percent composition. Does it tell you the percent composition? I'll go back and check. And then it says, so what about which isotope is going to contribute more to the average atomic mass? So let's look at that. So we have different isotopes. Notice this one is 85 hydrogen atoms and hydrogen 1, and then this is 95 hydrogen 2 atoms. Okay, percent composition is almost half and half. So let's change this up a little bit. Let's do something a lot lower. Let's say we only have 32 of those, and we have, all right, so we have 25% hydrogen 1 atoms. And we have almost 75, can't really see that, but almost 75% hydrogen 2 atoms. So then it tells me my average atomic mass, notice that it's closer to H2, okay? So that's that weighted average. The weighted average is based on the percentage. So it's kind of like your summative grade is 71% of your overall grade. Informative's only 29%. That's what it is. So the one that has the higher percentage is going to contribute more to the weighted average atomic mass. So as you play with this, that's what you're supposed to notice. So if you just don't even manipulate this and you're just looking at, okay, lithium, what does lithium typically look like? Out in nature, lithium is 92, almost 92.5%, the isotope that has a mass of 7. So lithium 7. And only about 8% is lithium 6. So what's the weighted average? It's closer to 7. It's 6.941. So the one with the highest abundance, which is the highest percent composition, is going to be the one that contributes more to the overall mass. So going back to this question, what conclusions can you draw? Well, you are supposed to say something about how the one with the highest abundance or the highest percent composition is going to contribute more to the average mass. Okay? So we'll talk a little bit more about that, but that's the conclusion that you should have gotten after doing these different simulation activities. And then we have a question. Actually, number 13, 14, and 15 are all going to pretty much be the same question. So I'm going to jump down to number 15, okay, and I am going to write on this. So I'm going to read this out loud. It says bromine's two major isotopes are bromine 79. This is the mass, by the way, of one particular isotope, and bromine 81. That's another mass of a different bromine isotope. Based on the average atomic mass given for bromine on the periodic table, which is 79.904 AMU, AMU is atomic mass unit, then what can you conclude about the percent abundance or composition of the two isotopes in nature? Really, technically speaking, it's asking which one's going to be more abundant, and how would you know this? So here's how you would answer the other questions as well as this one. So we're going to look at this. This number, 79.9, is that closer to 79 or 81? It's almost in the middle, but it's not quite in the middle. So which one is it closer to? Bromine 79. So you would say that the one that is more abundant is bromine 79. How do you know that? Because it is closer to this average atomic mass. Okay, and that's it. So I hope that helps. When you get to number 16, you can either Google this answer or you can just simply state it in your own words. You're not going to be wrong if you just word it exactly the way that you would be, talking to a friend over the weekend about chemistry. You can word it however you want. Okay? So I hope this helps, and I will see you guys next time.